Hi, my name is Saurabh Chattopadhyay, and I'm representing my company, Sterlite Technologies Limited. And well, if you go in the online schedule, the session is about SEBA trials in a multi-tenant FTTx environment. But we have tweaked the title a little bit here. We are saying that the session topic is driving FTTx network economics through programmable FTTx, and we'll just try to bring the coherence of these two different titles in next 20-25 minutes. So before I start the original discussion, so let me just also introduce the company a little bit, because it might not be easy for everybody to understand the perspective that we are bringing. So Sterlite Technologies is a data networking solutions company. So the line of business that we are in, we do solution engineering. And we also have another line of business under the same umbrella of company. And that line of business has a very small fiber last mile infrastructure back in India, which is rolled out in 6 different cities. And that fiber network infrastructure is offered as a shared infrastructure to some of these operators who are working out of India. So this line of business has some bit of understanding with the other line of business, and we try to leverage their field environment to trial out some of these things that we are doing with the SEBA. And some of these field trials that we have carried out so far, as we speak, we have something running there in the field, is giving us some interesting insight, and that's one of the things that we have captured here, and we would like to talk about it. And at the same time, we also want to bring to your notice that the multi-tenancy in the shared network environment is one of the very important use cases, as we think, which would probably establish certain new dimensions of benefits that we can achieve through SEBA. So having said that, let me just start by saying that, okay, so the context is shared economy. And of course, there are praises and criticisms. And for sure, when we talk about praises, we understand that shared cost, reduced barrier, green technology, these go without saying. But then having said that, there are criticisms, like people say that, okay, if it is a shared infrastructure, is it really my own infrastructure? Do I have the right kind of isolation or security for my services? Is the operations and maintenance is too easy, or is it going to be too costly for me overall when it comes to maintaining that shared environment? And then what about my customers' SLA? What about my end users and subscribers' experience? That's probably the prime aspects for my business environment. So these praises and criticisms, when it comes to in a context of FTTx and how that relates to the network economics, is something that where we started this entire initiative. So it's like more than a year now, we have invested time to start rolling out this trial in the SEBA, basically the SEBA version we wanted to roll out in this shared network environment. And while we did that, the thought process that kind of triggered this initiative is, we saw that, okay, there is a sort of a mindset for fiber deployment that, and this chart kind of shows that, mindset quite a bit. It says that, okay, if you are investing in fiber to the last mile deployment, well, at least 62% uptake is needed within 5 years time frame to do the break even. And if you're not doing that, then essentially your return of investment is pretty delayed. And that's where the fiber deployment not so long ago had always get challenged. But now from there, what we have realized is that things have moved farther when we talk about shared FTTx environment, because originally you'd probably just be able to project 30-35% of your market for a particular geography. But then if you're being able to set up a shared environment, then definitely your projection scope increases. Now from there, with the evolution of this converged multi-access implementation, we are realizing that the overall uptake is definitely going to accelerate in a significant way. And with that acceleration, the CapEx infrastructure return of investment is, and it's just not CapEx actually. I mean, when you do fiber rollout, there's a lot of cost comes on the rollout, the rollout methodology itself. Like, you'll actually have to invest quite a bit to, have the underground fiber rolled out or the over the top fiber rollout. And all that investment is, if you're getting the right kind of use cases which you would like to roll out on top of that fiber deployment, if the duration of uptake is reduced, then definitely the CapEx is not going to be the prime cause of concern for fiber rollout. Now, what would be the, and that brings us sort of an inflection point in the fiber rollout business, because people start seeing that, okay, there is a return of investment that is getting matured today. But then with that return of investment promise, what comes as a sort of a flip side of it is that you'll have to introduce the right kind of operational infrastructure to establish that shared environment manageability. So how do you maintain service isolations? How do you maintain continuity of services? What are the operational overhead that you're going to reduce? These becomes the prime challenges for FTTx shared environment. Now, when you're talking about that sort of a complexity, the complexity, when we are dealing with this complexity, what we realize is that it's really, it can be handled in two different ways. In fact, both the approaches will have to work hand in hand. One part of it is how much complexity you can handle during planning that last mile infrastructure. Now, that last mile infrastructure planning is now having multiple facets to it. Now, what are these multiple facets that we're referring to? We're talking about a converged access infrastructure, and that converged access infrastructure is now having those implementation challenges of rolling out fiber to the last mile for 5G base stations, rolling out fiber for small cells, the densification requirements that are coming in the last mile network. Now, if you look at the the challenges that will come with that kind of converged access network planning requirements, there are challenges in terms of how do you establish the scalability in terms of bandwidth, how do you establish the low latency requirements. There are layer 2 characterization that will demand a lot of focus. And because of those layer 2 characterization requirements, even your layer 1, which is basically a distribution network, will have to change. You might not be able to use this traditional 1:64, 1:128 distribution in the real field environment, because your latency requirement, your capacity requirements, your ways of dealing the entire network architecture on top of the GIS map will change the exact fiber rollout plan that you would be carrying out in your particular environment. Now, because of this, now this is a very simplistic view that we are showing here, that how what kind of planning challenges that will typically come when you are actually talking about this kind of a fiber rollout infrastructure. And with that infrastructure, what kind of fiber capacity planning that will have to go in. And this probably is something that you can cater to in terms of planning the network architecture. The second thing that comes is how do you handle the operations part of it. So 50% of challenge lies in the planning, and 50% remaining lies in the operations. That's one of the observations that we have made. Now, when it comes to operation, if you look at a traditional central office profit and loss structure, now this is really an illustration. So these are these are illustrative figures. But then in the illustration, what we are showing is there are two sets of numbers. One set of number talks about a typical central office operation, expenses, and how the operation expenses are bucketized in different heads. And then with that that set of figures, where exactly the operations can be improved, how the operations through programmable FTTx or SEBA kind of implementation can bring the benefits. That's the second set of figures that are highlighted on top of these previous set of figures. And these are the green boxes that are showing up those figures. So essentially what you're saying is that with PFTTx, with the possibility of having a common NOC environment with multi-vendor implementations, there is a significant O&M reduction that we foresee coming. Then with the ability to have isolation programmed for entire PFTTx channels. Like for example, what happens today in a shared network environment, you either go for fiber unbundling, which is like dedicating the fiber for every tenants that you have, or you have bitstream unbundling or wavelength unbundling. In all of these cases, what you do really is that you dedicate something or other to each of the tenants who are getting the service from you. But then with PFTTx or with the SEBA kind of environment, we see the possibility of making that unbundling programmable itself. Now, if you have that ability to establish a programmable unbundling strategy for your multi-tenant environment, then what comes out is that your ability to manage that unbundling strategies again at the software layer, it brings the flexibility, it brings the automation, it brings the the agility that you would require. All other standard approaches that are in practice today would never give you this flexibility and agility that you would require. So with SEBA, this programmable unbundling is one approach that essentially will establish benefits with not only the operations, but also security and risk mitigation. Because in most cases, when you have a shared environment, the risk mitigation becomes very important because you are always working under extremely tight SLAs. Your operator customers expect you to sign up with stringent SLAs because they don't want to falter on their customer services. And those stringent SLAs, if they are missed, usually that causes a lot of concern, and the risk mitigation cost becomes high. But with the dynamic behavior that you are being able to cater to with the SEBA implementation, the risk mitigation cost lowers. So these operation and planning, both, well, for planning, SEBA probably won't be able to do much, but then for operations, the benefit that we see coming from SEBA is substantial. And with the proper planning, these benefits can be actualized in a much greater way. And this is something that we have been trying out in that network that I was referring to, the SNL network. Now, what we did is we actually, we took one particular central office, and in that central office, we pretty much, established the same, architecture, the SEBA reference architecture that we keep talking about, along with the trellis architecture. It's like a trellis plus SEBA combination that we implemented. And well, this particular picture is showing the forward-looking view as well. So far, what we have implemented is for the residence part. But we are essentially moving towards implementing the other part, the enterprise part and the base station part as well. But we haven't got there yet. But then with the residence part, the residences, the ONUs are rolled out to the building sites, and then the central office has been re-architected with the compute as well as with the OLT and the trellis infrastructure. And we are running that SEBA reference architecture there, SEBA exemplar there, and with that we have made a progress to see how things are shaping up. So just a quick look at what exactly we are running here. So what we are saying is that we have these ODN termination MACs, basically these WNUs and WNTs, and then we have these layer 2 MACs, which are basically OLT MACs here. The agent, basically it's the same driver, OpenWLT driver that we have, which is essentially what we have from ONF, open source, and we have done some curation there. And then we have these hardware abstraction layer, which is essentially Volta, and then the integration layers above. And these are something that comes directly from SEBA. And then there are a few proprietary parts that we also have used to make things a little more user friendly for our NOC team, because this NOC team that we have in our other line of business, they have a certain type of skills, and they have a certain type of requirements to see certain things in a certain way. So we have some implementations to support that as well. And with this kind of a FTTx solution deployed in that SNL network, we have observed two significant dimensions. One is that when we started this, and when we started doing the SEBA lab trial, and we tried to see what are the control plane performances. So essentially we focused on just the control plane performance for now, because this was the most challenging part for us, because we realized that the hardware part is something that our partners are already taking care of, but then the software part is something that requires, it's a SEBA software. We wanted to ensure that we are running it in a best possible way. And when we did that, we realized that there are some bit of challenges in terms of the responsiveness in some of these control plane parameters, in terms of speed, accuracy, and reliability. But then when we started doing some modifications at the deployment environment, so we used a SEBA exemplar with the standard deployment approach, we got some performance figures. And we even talked to some of the operators who are guiding this SEBA track, and understood from them what will be the direction, what will be the right way to build the right kind of scalability in the architecture, and what is the target really, where should where should we be getting to. And then when we spent a couple of months to change this deployment strategy a little bit, and we came up with our curated deployment strategy, we realized that we have got 8 times gain in the control plane performance parameters. So that's number one. So with the change of deployment strategy, and we're talking about Volta 1.x, we're not talking about 2.0. We haven't been able to migrate to 2.0 yet. It's in the roadmap. But then even 1.x is capable to provide 8 times more performance than probably what some of us might have seen in our labs. And that's a significant confidence booster for us, because when we tried convincing our NOC team, the kind of conditions that they put, we could satisfy those conditions with this approach. And with that, this 8 times performance gain gives us that sort of a trial readiness. And then we rolled out the trial there, and we have been running it for a couple of months now. And there were challenges initially. I would agree that there are things that are not in place in some of these layers. But then we came up with a sort of a preventive maintenance approach, which we followed in a certain frequency. And then with that preventive maintenance approach, we are being able to run the trial with these parameters. So TL9000, some of these TL9000 metrics is something that are measured by our other team. And when we look at the data from them, we see that they haven't got the outage for these, after we implemented that preventive maintenance strategy, there's a 0% outage. The complaint report ratio is manageable. They're not complaining. The mean time to restore service is, of course, it's a combination of what we get from SEBA and what the NOC team is supposed to do. The fixed response time and for priority 1 and 2 and the lower priority aspects, most of the figures are appearing to be manageable. But having said that, we should, of course, to be very candid about it, we're not saying that the SEBA is still production ready fully. There are things to be done, because otherwise, the preventive maintenance approach that we've implemented, it's going to be overhead for everybody. But then at least this gives us a confidence, a great confidence for that matter, that the way the entire reference architecture is shaping up, the way we are being able to implement and deploy it is something that is suitable for even a complex environment like a shared FTTx network. And quite a bit manageable as well, even with the sort of the previous version of SEBA, because 1.x is pretty much going out now, and we are talking about 2.x, and we'll be migrating on 2.x. But then overall, the architecture has that stability in place. So that's what we are realizing, and we wanted to take this opportunity to spread the message here, because in some way or other there are apprehensions that sometimes we see coming from different stakeholders, and our own team has apprehensions, as I've been telling you, right? So, but then the reality is that the production readiness is not too far, and with the kind of support we have got from our partners, right? It's really getting there. So this is something that we're launching. So we also have a version that we are demonstrating in the demo area, booth number 11. If you would like to see the version that we're running there, please come by. We'd be very happy to show you what we have there.
Well, thank you. Thank you so much. So please, when you speak, close to that. Find the microphone.
All right. Thank you. All right. The question on essentially sharing the infrastructure, so that's different operators that you're working with, okay, and so they had some visibility to it as well.
Well, yeah, so we have a certain level of ownership of the entire environment, and as long as we maintain the SLA, they are very abstracted out from the infrastructure and what we maintain in the infrastructure. So it's kind of our purview in the given given state of affairs. So we don't have to have a so-called permission from our customer operators, as long as we maintain the agreements and SLAs.
Okay. All right. I'll let someone else ask some questions. Thank you.
So a bit of a follow-on maybe is, so in a fixed access network sharing type of an arrangement,
yeah,
oftentimes one of the biggest topics is getting SLA performant data out of the system. And so did you find from an overall SEBA architecture that the interfaces were there and or the raw data was there that could be extrapolated in a way such that network partner A data was visible or made available to report that SLA, and then of course was not visible to partner B and C? And
yeah. So right now the multi-tenancy support in SEBA is at its infancy, I would put it that way. In fact, while the SEBA specification was getting designed, the 0.7 version is where I worked with Sean, and we kind of from Sterlite side we requested some updates there. So the specification has the provision for catering to the multi-tenancy requirement, but the reality is that the exemplar platform doesn't have the right multi-tenancy architecture in place. So we had to do a lot of ad hoc work to ensure the separation and isolation. But it's, I think, I mean, this is also one of the points that I wanted to mention here. Probably, I mean, at least from our point of view, we think that this is really an important use case to consider for SEBA exemplar.
This is really an encouraging thing. So what is the scale of your deployment?
Yeah, the scale is not big.
Okay.
The scale is not big. We need to work more to go to 1,000++ level of scale. Okay, we have our network is like connected to 200,000 subscribers, but then this trial scale was much smaller.
Thank you. And seems like you have made whatever trial towards the production ready. So could you share what you had to do as a preventive measure, or it is a IP of Sterlite?
So yeah, I mean, there are, of course, there are some IPs and there are some proprietary implementations that our network team has, and there are certain implementations that we have to do to maintain that proprietariness, the sanity of their intellectual properties. But otherwise, I mean, from a performance point of view, it is primarily the deployment, the way the deployment is handled, right? I mean, it comes to Kubernetes networking, it comes to the way the the CPU affinities are maintained, it comes to some of these basic building blocks that you have in the deployment environment.
Thank you.
On the Volta 1.x, right? So the Volta itself, the core has the clustering support. Do you deploy the Volta 1.x with the clustering?
Yes.
Okay.
How is the SLA enforced? Is that on like a BNG or?
No, so the SLAs are, so mostly these parameters that they have, SLAs are around these parameters. I mean, you're talking about our network's SLAs, right?
Well, I was thinking of the subscriber level bandwidth profiles, those kind of things.
Yeah, so this is like, for us, it's a B2B SLA. So it's like, from our side, we sign up the SLA for the operators, okay? An operator may not have the SLA with their subscribers, but we don't know much about it, but then what we sign up with the operator on a B2B SLA is what we need to maintain. That's the primary objective.
So is this a sharing of the ODN or?
Yeah.
Okay.
Yeah.
Okay.
Yes, so this is sort of an open source philosophy question. So you did some work, which is normal to say, we're going to do something, experiment with it, test it, that's not the exemplar. So is your philosophy to upstream back the changes that are core to you, that you think are of value, so that it makes it easier for you to just pull this forward as you move along, and then where there also may be opportunity for another community member interested in multi-tenancy?
Sure. So whatever changes we have done on these blue boxes are, either already submitted to the Volta and SEBA Git, or they will just be submitted in a matter of few weeks. Okay, but the way we have achieved multi-tenancy is more of a surrogatory level. So it's more of ad hoc level. And what we really want to do is we want to design that multi-tenancy architecture in this community itself, if the community considers that as a priority.
Well, thank you so much. I think these are very good news about the production. I think we're working on to get Volta 2.0 stabilized. So thank you so much.
Thank you.